Hey guys, welcome to the show. Today we're checking out z.ai. Now, they have released GLM 4.6, actually got a response. You can actually run the massive model on pretty much any computer now. I think that's amazing. Now, I have actually been using GLM 4.5. It is a great model. I've been planning to do a video about it, just showing some coding, all that kind of stuff to do, but I don't need to do it anymore because 4.6 is out. And apparently, look at that, it says superior coding performance. And they got like these benchmarks are just destroyed now. 98.6%. It destroyed the latest Claude, destroyed DeepSeek, and it destroyed the GLM 4.5. So apparently this is an amazing, it says it's a general model, and it is a general model. You can ask it questions. We'll do a whole bunch of tests, but superior coding is what it's all about. So I actually have a treat for you guys. I'm going to be using Inferencer, and in the latest version of Inferencer, there's actually a mode where we can run the full unquantized model. Now, you have to go into settings here, and it will require 700 gigabytes of memory if you want to run it in memory. But if you want to run it off the SSD, you can set that to 100%, and apparently it will only take 15 gigabytes of memory required, and you can run it straight off the SSD. And as you can see, we have actually got a response. We're getting 0.03 tokens a second, and it's churning away. So I get it, it's slow, but the fact you can actually run the massive model on pretty much any computer now, I think that's amazing. This is useful if you want to find out the raw generation. What is the truth based on the model? Because when it comes to quantization, the maths skews it a bit, and it can go a bit trippy. I found that anything Q6 and above is really almost perfect, but we're going to be testing out with the raw, the Q6, and I've got the Q8, and we're going to find out the best version to run. And the best version to run is, I'll upload that and you guys can all use that quantized version. So I have with me today, I've got the Q6 and the Q8 version. The great thing about this model is, if I did want to run it on Mac Studio, it will only take up around 300 gigabytes of memory. So you can actually have a few models running on the chump with this. So let's just get this loaded in. We're going to just take it straight off the SSD, load it straight into memory, and we'll do some tests. And what's good about this model is it's only 300, let's just read right there, it's only 357 billion parameters. So it's not a massive, you know, I've been a bit spoiled. I've been trying out, you know, 1 trillion parameter models, 600 billion parameter models, and it's not about the size of the parameters, because as you can see right here, like DeepSeek, that's 671 billion parameters, and this one is half the amount of parameters, but apparently it's got better scores. So yeah, let's just see how it goes. So the model is almost, it's into RAM right now, and we'll start off with just tell me about yourself. Just want to know a little bit more about yourself. So it's a thinking model, as you can see here. So it's just deconstructing users' requests, blah, blah. And we're getting about 17 tokens a second. As of last year, they have over 200 million users, and they're about to IPO in China. So they're a big deal. I think they recently just got $1 billion in investment a couple of months ago. And they're all about, this is an advertisement for them. I'm just interested in these companies. And they're all about teaching machines to think like humans. And what I love is, I was chatting to it earlier on their online website, and they say stuff like the decision to open source their models was a masterstroke. So I really hope that they continue to open source these models, because as you can see, it's very coherent, a very beautiful response coming here. So there you go. It's thought all these amazing thoughts. So that is that. It's very coherent. I like that. I want to see if we can disable thinking, because sometimes I find thinking annoying. So let's just see if I can add in a think token. Tell me about yourself. So it's definitely got a think and a think close tag, and it's definitely just answering straight away. There you go. So you can just disable thinking by adding in the think tag right at the top there. And it says, I'm a large language model trained by Zhipu. I am designed to understand and generate human-like text. And it was getting 15.88 tokens a second. And our memory usage, we can see that we were using 267 gigabytes of RAM. So now that we've done that, let's ask the age-old riddle that confuses all large language models. And that is, I'm allowed to think, The surgeon who's the boy's father says, I cannot operate on the boy. He is my son. Who is the surgeon to the boy? So it's going ahead and thinking. And yeah, thinking, I personally don't like the thinking models. This detailed deconstruction of the thinking based on such a simple prompt. I personally don't like that, but maybe this thinking situation is what gives it such high scores. So maybe when it comes down to when we do our coding exercises, maybe these thoughts are going to help it answer the coding correctly. So the surgeon is the boy's father. It figured it out. Now, the surgeon is the boy's father. Now, this is actually a great result because it's actually analyzing the classic result versus your version. Now, I've tested DeepSeek. That one failed. It said it was the mother. I've tested a lot of models. Claude, that failed. It said it was the mother. GPT, that one failed. It said it was the mother. Whereas this one, with all that thinking, it figured out that there was a twist on the classic riddle. I'm just going to ask it again, that same question. And I'm going to ask it not to think, to see if that will confuse it. Look straight away that. So without the thinking, it says straight away that the surgeon is the boy's mother. Now we're going to jump in and just check out the token entropy. And we can see that it didn't have any confusion about it being the mother. In fact, I'm going to jump in and just actually see the percentages. And there was a 9.28% chance that it would have said father, and an 88% chance that it's a mother. Now I'm going to force it to actually give the response of father to just see what it thinks. And the surgeon is the boy's father. The riddle solution is that there is no contradiction. The surgeon is simply saying a fact. So that's actually interesting. So actually, even though I forced it to say father, it didn't really want to say that. It went with it and actually answered it as if that was the truth. Some models, if you force it to give a response, they still want to go back to their training. And as the classic riddle is about gender biases, that the surgeon could not be a female, which is why most of the big models that have massive amount of training data, they usually fail and say that is a mum because they don't actually reason. But we saw from the demonstration there, but without reasoning, without the whole thinking monolith that it thought about, it wasn't able to figure out that the father saying that he's my son means he's not the father, but it figured it out if you do have to think. So that was pretty good. Now I'm going to say, let's write a story, and I'm just going to disable thinking because I find that annoying. So straight away, it's just writing story. Elera. That's a really cool name. I haven't seen that name before. I'm going to jump in, and it just wanted to start off with L. That was a contentious opening. It might have said it could have started with Arthur. Not grand. So I actually picked the second one during our selection. I've got the token temperature set to 0.1. So it's very close to always picking the top one. But in this case, it picked the second most top one. Now, actually, I love this response for the main reason it's not about a lighthouse. Most of the models I've seen llama, GPT, OpenAI's version, all of the big models, they tend to talk about lighthouses a lot. I've read a lot of stories about lighthouses, except this one, I just gave it the prompt, write a story, and it's actually come up with something original, an original name, Elera, and an original story about a windowsill getting repaired by her. So if you are looking for a bit of inspiration, this is definitely a good model to consider. And that was even without thinking. So if I add in the right story with thinking, write a story about Python. We're mixing in the superior coding performance with our write story, and it's gonna go ahead and think, deconstruct the request, use a story about Python. You can actually see what it is telling you it wants you to see. So the whole thinking training that it's gone through about brainstorming, all that stuff, you can actually see its reasoning. And the thing about the way this stuff works is every single time it writes a token, that makes it more likely for it to say that token in the future. So it laying out the plan makes it relay, because you're twisting the weights towards the tokens that it's already selected in the thought process, which is why it gets a more accurate response. So for example, previously when I said that the surgeon is the boy's father, based on me saying father, made the multiplication lean towards having father a follow-up round. Earlier on, we did a test with GPT OSS, and it said that the presidential election of America was in 2023 by mistake. And the first time, because it said 2023 the first time round, the second time round, it just went with it and kept on just repeating it, saying 2023. So the weights bias the responses. Now, this is a really long reasoning chain. It's really getting into the depth. We've spent over 1,000 tokens of processing, and it's still just figuring out how to write the story. But what's good is we saw is you can disable thinking, and that will just get to the end crux of it. And for this application, I'll probably add in a user interface where you can skip thinking and maybe even program the prompt a little bit to make the thinking a bit more concise and all that stuff. There's a lot of things you can do internally when you get and dig in the details. As you see, it's got the premise, and the first lesson is going to teach Ellora. So stuck with Ellora. Ellora is still our character. So this is just purely based on the training data. Maybe they found that there was a lot of Sophias out there and they just wanted to make it a less common name to show that they're not, copying everyone else. They just want to be a bit unique. Or maybe they believe in their statement that says teaching machines to think like humans. So all these humans out there, when I ask you to write a story, do you think of the word name Ellora? Yeah, they're thinking to think like humans. So we got a nice story there. We spent 2,000 tokens. It's just having the world of time. It's mixing code inside this prompt. Over the next few days, Pi became Ellora's guide and partner. They didn't give her answers. They taught her how to ask questions. This is a very, very impassioned speech. It looks like something nice is happening in the world. So we spent 2,500 tokens already, and that is thorough. I can imagine a lot of kids probably using these specialist models to cheat on their creative writing, because if everyone just uses OpenAI, then everyone's going to get the same answers. Whereas if you start mixing and matching models, you're probably going to get different experiences. And it took in total just under 200 seconds, around 3 minutes worth of processing, and we got a first pass on the story. And of course, if you want to, you can always just say continue. And I'm going to say, don't think anymore. Just stop thinking. And yeah, it just continued on the story. So we got a nice pattern of execution. Definitely a beautiful model. But a lot of people, what they love to see, and the advertisement of this says superior coding. So we spent a lot of time showing you this generally creative writing and stuff. We're going to jump into coding after we do maths. So we're going to press new here. Show me the top 5 maths formulas. And one of the good things about this, actually, if you are interested, they've actually increased their context window from I think 128 to 200,000. Now, if you ran a prompt that large, just paste it in your code base, it'll probably run at 1 token a second. But if you're running a prompt that large, you probably want some deep thinking into there. So maybe that will be awesome. Still be good. Or you can split it up and all that stuff. So we got some formulas over here. As you can see, the maths is printed out over here. And got some nice printout there. So it's mixed in. If you look at the code by raw, it's, I think, using latex. So that's that $. And it's using this, but it's written it out in a compatible way that markdown renderers, like this one, can understand it. So we've got compound interest, how investments grow over time. So that's very, very beautiful. It can do maths, it can do creative writing now, and it can even do reasoning. With thinking, we found that the father was considered the father as long as you got it to think about things. But now let's get it to do coding. And when I use GLM-4.5, I was actually impressed with its coding ability. It coded really well. So I'm going to just start off with write a 3D racing game in HTML. Then all it's going to do, I'm going to let it think about it, because maybe the thinking is what gets it to 98.6%, 98.6 in AIME 25, destroyed all these models. So maybe I'm just going to let it do its thing. It's already printing out the results there. It's called a 3D speed racer. I'm excited to see what actually happens. I'm excited to see this is Q6. So by default, the version that they released, the raw version, is float 16. And that's the full width of the float. So it gets very, very minutiae details, especially when you're considering all the actual tokens and the parameters inside. So you get everything in there. Usually a lot of people, they release a half size one, and that one's float 8. And that's half the size. They do prioritize some layers depending on the people that you choose, but that's half the size. Q6, I found that very, very close to Q8. Q5, you start losing it, and then you can do little mixes, prioritizing different layers to get the truth. Q3 and above is still very, very usable, but you need to be more in tune with the whole prompting. So for example, instead of asking a question, you need to force it into a corner or ask both questions. You can say, can you do this? And then say yes. And then can you do this? And say no. And usually if you get two positives, it means you're on the truth. So for example, if you say, can you do this operation? It says, yes, you can. And then you say, can you do this operation? And then force it to say no, it'll say, no, you can't. And that way, you know that there is a bit of contention there. Whereas sometimes if you force it to say no, it will say, no, you can't. If I was being dishonest or if I was lying to you, but yes, you can. No, you can't. It usually corrects itself if it is if you force it to say a negative. So that's one way to work with low quantized models to get some sort of accuracy. But yeah, let's just see what this does. We've got 2,000 tokens a second, 16. So we got 2,000 tokens a second. That would be pretty cool. Take that back. We've got 2,000 tokens generated, 16 tokens a second. And this is Q6. So it's very, very highly accurate. Let's look at the code. It's not really doing much. It's just set up. This is CSS. So we're just at the CSS phase. I've given it a lot of bandwidth to do whatever it wants to do. And hopefully I've got a good token limit. I've got 10,000 tokens as my limit. Phew. I'm going to make that tab modulate the limit in real time. The memory offloading can actually be done in real time. So if I wanted to, I can actually enable that right now and it will start to slow it down. I kind of don't want to do it because I don't want to ruin my tokens a second, but I'll do it just to show it. So for example, if I make it 50%, it's slowed right down. It's using half the amount of memory, so 130 gigabytes. As you can see, it's pretty much like one token every 3 seconds. And I can offload that 20%, speed up a little bit. And all it does is it means that that massive model, the 300 gigabyte version, plus 20% of it is getting streamed in from the SSD every single generation, every single token that needs to be generated, 20% of it. So that's going to slow it right down. I'll make it 5%. Now it's getting faster. Look at that. It's writing it. And this feature is actually kind of cool for one reason why I like it as well is that it can actually be modulated in real time. So for example, if you want to run another application that requires a lot of memory, you can actually just ditch the memory, offload it completely to the SSD. It's still going to be generating. Your computer's resources are going to be very, very open apart from the SSD. That's the one that's going to be getting attacked. But as you can see, my graphics processor is not getting attacked whatsoever. It's very, very low because the bottleneck is streaming out from the SSD. And here we will only be using 5 gigabytes of RAM. But once you finish the application that's a memory hog, you can switch it back into memory offloading to 0, and it's going to stream it back from SSD into memory, and then it's going to start writing fast again. So as soon as it's got the model back into memory, this model takes about a minute. So it's like a minute's wait. One of the good things about streaming from SSD though, if you don't know about SSDs, they do have writing lifespan issues. So if you're writing lots of data to your SSD, you can actually, you're wearing it out. But reading from your SSD doesn't wear it out. Now don't quote me on that. Double check your research. That's what I read. It says you don't wear out SSD by reading. So yeah, so that's one of the good things about SSD. So look, we're speeding it back up. So we slowed it right down, speeding it back up. You're in full control of the offloading from memory, so you can mix and match apps. Maybe in the future, I'll make an auto mode where you give it like a limit of memory to use or a dynamic limit of memory. When you have more memory free, you can prioritize and feed in more layers for it to process. And when you have less memory free, it can tune it down. Kind of what the operating system does. But when the operating system does, it can take over your system and it goes a bit haywire when it gets into a situation. The screen starts getting multicolored and then your computer gets reset. So having a bit more control is good. So even though we slowed it right down, we've still got 10 tokens a second on average. And it would have been 16 tokens a second, but because of my slowing down, it slowed everything down. We've got over 3,500 tokens. So I gave it such a simple prompt. I said a 3D racing game in HTML, and it's just generating these tokens and it's generating really well. I'm hoping this is just gonna print out some amazing results. And I think this is the version I'm just gonna publish. And you can, if you don't have enough memory, you can run this. So this also runs on my MacBook Pro. It doesn't have 512 gigabytes RAM, but you can run it via the SSD storage, but it'll be like an overnight operation. So rather than it being maybe 10 minutes or 5 minutes to get some comprehension, 5,000 tokens, you probably just go to sleep, wake up the next day, and hopefully you'll be half done. Maybe it's 1,000 tokens an hour. That kind of situation is what you're going to be getting with this model. But of course, I'll do a test with the full fat float 16 version to see if I can actually get response, and I'll leave it running overnight so I can do some perplexity tests. I'll get the full fat response and check out the Q6 and just see how much loss we get by comparing that result and feeding it into this one result and just seeing the token probabilities, how they change based on that situation. So the results are in. I've created an immersive 3D racing game, and it's 4,000 plus tokens. Maybe it's 4,000 tokens in general, because probably 1,000 tokens for the thinking and 500 tokens here, and we still generating, still writing away, and we got some stuff. I'm just going to copy this in and just see what it does. Now, this code looks mostly CSS, so I'm not going to give it too much credit. It's just that's just CSS speedometer. That's a div. I'm not sure if it's you got an update car, so there's an update tick inside the game engine. Speed is, you got the friction, create particles, create checkpoints. I don't think there's much meat to this game, but let's just see if it did find anything confusing. So it was mostly, it wasn't sure if it was going to call it map here. Let's just see, what was it going to call it? It could have called it scale. It was figuring out life. But generally, most of the code seems to be, it was 100% certain that it was going to write that word that it wrote. So this is probably just coming out of its training data. It's probably seen some open source code that they've got it and it's fed it in through here and it's just regurgitating it. That's what it looks like to me. But we haven't given it a more advanced prompt, gave it something basic. Spent a lot of time on this, so I'm hoping this is going to be working. We got something on the screen. Look at that, hover effects. Looks very beautiful. Got WSAD to steer. And this is actually better than I thought it'd be. I thought it was going to be a mess. I thought it was going to be awful. And now what's the speed? I'm not really going too fast. We got a little mini map over here. I wasn't expecting this. Now, I thought it was going to be 3D as in 3D perspective. And it is 3D. You can see the shadow there. Oh, what's that? That was a hello. All right, wasn't that clever? I kind of lost it. But I'm going to go into chat. I'm going to give it the exact same prompt. And you know what? Let's add in Claude. That way we have that what it says. It says it's superior than Claude. Let's see. All right, so I think Claude's won it there. That looks like the racing game I was expecting. That's more fun. GPT OSS. That one is beautiful. It's actually better than it was last time. Last time it was awful. So I think it's definitely getting better. I think for GLM, probably it took HTML a bit too seriously, whereas the other guys, they used libraries, they use 3JS. So I'm just gonna give it one more shot. I'm gonna give it the prompt to use 3JS just to make it a 3D scene, because previously I said HTML, it might have thought that I didn't want to use proper 3D. That's why it limited it. So I'll give it one more shot. This time it's thought a lot less, and it's going to use 3DS, smooth controls, track system, engaging gameplay mechanics. All right, we're done now. 6,000 tokens. This time around, it's got a skybox. I can see it. End race, it's got laps. What is this? What is this? Oh, it's too good. Oh, what is this? This is amazing. Okay, look, it's broken, but this is, it's got collision detection. I just don't know how to use it. It's got a mini map. It's got potential. It's got, whoa! The controls just aren't working, but that is impressive. I just done it. It's got a little map right there. If this worked, it would have been the best version. If this worked, it would have been the best version, because there's definitely a track. It looks like, look at here. This is OpenAI. This is ChatGPT. It's nice. It's got shading. It's very, like, the prompt was very basic. So maybe this is the best version there. This ChatGPT version. It's got shadows, it's got a box. I'm sure if I give it more stuff, it might break it or make it better. You got this guy, which is like for people that are in the San Francisco scene. They're always microdosing. So yeah, but this is definitely beautiful. The original version looks very, very basic now, but it didn't use Three.js, so it just tried doing it all itself. It's got a lap, it looks beautiful. This version though, it's got like a countdown, it's got trees, it's got a racetrack, it's got a camera transition, it's got a mini map. Look at that. I just don't know how to control it. Or is it controlling right there? The controls are a bit wacky. That's the only thing. But that could just be because of the quantization. Maybe we need to use the 8-bit quant. And I do have that available. So that's just something to consider. So I think this could be the best version. You got lap 1 of 3. So if the controls worked, you could probably fix it with the prompting. You can say, hey, the controls are working. It's the user's reporting. It's probably articulating my thought better than my thinking. And it's saying, look at the code. I can see the issue. Update car form. The problem is how I'm calculating the forward vector. The calculation is correct for getting forward vector based car's rotation, but I think the issue might be how the initial rotation is set up, how steering is applied. I'm just going to give it a shot. Definitely had potential. Wrap up the show. I'm going to switch over to the full. This is 665 gigabytes, so it's float 16, the maximum one. I'm going to see if I can get this running. I'm going to dedicate 50% of my computer's memory to this, and I'm just going to say write a JavaScript timer, and let's just see what it does. And it's going to be very slow, but if we hopefully it will work. I've been testing it on the GLM-4.5. This is the first test I'm doing with 4.6. It works on 4.5. I got that working, so we can stream the data directly from the SSD rather than it staying in memory. So if we start getting some tokens out, that'll be really good, because that way at least we can know the 100% truth of the unquantized version of the model. And that way we can find out if our Q6 quant is deviating or is it the Q8 quant. And yeah, and the best one, I think the Q6 version is definitely good enough to upload to Hugging Face based on that result, 3D racing game. So I'll definitely do that, so you guys can download it as soon as it's up. It's probably taking me a couple of days. But yeah, let me know your thoughts of this. It was cool. Just GLM 4.6 apparently is superior coding performance, but it's a general model. You can definitely ask it to do lots of different stuff. From z.ai, over 200 million users. That was last year's figures. It probably has more now, and they're about to IPO in China, so they're just on the up, and they're proud that they're open sourcing. So they've actually open sourced this model faster than they've updated their website. So if you go to their website, the foundation models, they don't even have 4.5 on there. So their model development team is faster than the marketing team, which is probably a good sign. Because I know the big companies over here, they usually market first and then they release a shoddy version and then they fix it up a week later. Whereas these guys, they release the model and then they check it out. And as you can see, we've processed 8 tokens already in the prompt processing. So we should have a response very, very soon. All right, so let me know what you think of z.ai GLM 4.6. Amazing, amazing stuff. Hope you guys found this video useful and enjoyed the show. Actually got a response. We're getting 0.0. You can actually run the massive, massive model on pretty much any computer now. I think that's amazing.